Good day everyone. In this video we'll show steps to calculate sample size for survival. The outline of this video is going through the concept of calculating of hazard ratio. Then we'll show how to convert hazard rate to survival and vice versa. And then calculation of sample size using PSS of Vanderbilt University. And then we'll show the same example using R. Then we will show how to calculate sample size for survival in case of non-inferiority design, and finally we will show how to calculate sample size in case of Cox regression with covariates. First, let's check the concept of calculating of hazard ratio. Here is a very simple example adopted from Biostatistics Primer, what a clinician ought to know hazard ratios, and assuming this is the first and second and third time periods. Here are periods in weeks, but it can be in any other time units. There is a treatment arm, experimental arm, and control arm, and at every time period the number of patients at risk are recorded. For simplicity, it will be 100 patients in experimental arm, 100 patients in control arm, and then we check the number of patients died during a time period. For experimental arm it was 3 patients, for control arm 4 patients, and then we calculate the hazard rate, and here it is the rate of patients dying, which will be A over B. That means the number of patients died in a time period, which is the first week, divided by the number of patients at risk for each arm individually. So it will be 0.03 for experimental arm and 0.04 for control arm, and we can see that the hazard rate is greater in control arm or is less in experimental arm. And when we divide the experimental by the control, it will give me a hazard ratio of 0.75, which favors, of course, that experimental arm is better than the control arm, since it is less than 1. What we can notice here is that the hazard rate changes by time period, but the hazard ratio is almost constant.